Hello everyone, I'm Patrick, and this is a quick demo of the libp2p v4 swap agents that I've been working on under the leadership of Manoj. So basically, this is an autonomous DeFi agent that discover each other over P2P network, alongside verifying identities cryptographically while executing Uniswap v4 swaps and coordinated trades through trust-aware reputation scores. So we built this with the Rust libp2p library and the Uniswap v4 hooks, and it is deployed on the Sepolia Ethereum testnet. So right now we have two terminals opened and two agents connected. So the two agents, right now we're in simulation mode, and we have multiple modes. We're in simulation mode, so we have multiple modes. We can off the simulation mode and go to the live network, or we can move over to the local Anvi testnet. But for now, we're doing everything on the simulation mode, whereby everything is going to be simulated. But whatever works, but everything that works in the simulation mode also works in the other two modes. So the P2P, the agents on the network discover each other via MDNS and automatically exchange EIP 191 identity attestations, binding the peer-to-peer ID to an Ethereum address. So let's quickly make a swap. But first of all, let's quickly make a swap. So we can just say swapping one token A against token B, and it will be broadcasted to the network, and the trade will be executed. Remember, we're in simulation mode. If we're in live mode, the transaction hash and everything will be a natural transaction hash for the Ethereum network. Then alongside, we also have the intent signaling and execution mode, whereby the intent command broadcasts the swap intention with optional price bands. This is separate from the actual executions. So we can say intent. And it is broadcasted to the network. Okay, so I'm saying here I want to swap 10 token A for token B, and it's going to be broadcasted to the network. Also have the reputation scoring, whereby agents track their own activities. So after a number of swaps, the agent score is increased. But right now, we have made one swap, so by default the reputation score is 0.35, but because we made a swap, our reputation score has increased a bit to 0.448. Okay, so if we make more swaps, you can see our reputation score will increase again. You can see now it's 0.53. Okay, we also have conditional swap. So conditional swaps gate execution on the agent's or reputation, whereby if the agent's reputation is not up to a particular threshold, the swap would be rejected. Remember, the agent score is the trust level of the agent within the network. So let's see this. Let's set the threshold to 0.9, and you can see the swap was conditionally rejected because our reputation is too low. But if we were to set it to something less, let's say 0.3, you see our swap was executed. Okay, so we can also propose to the network that we want to make a swap. So you can say propose A to B on So we're proposing the network that we want to make particular amount of swap. So agent B accepts and automatically executes the counter swap, and agent A gets notified to execute its own side of the swap. So yeah, that's basically it. Then one other feature we have is the Filecoin. What's it called? We also have the Filecoin Archival, whereby every swap and identity attestation is buffered locally. So in this demo, we'll not be covering that, but in the previous demo, we have already covered that, and our record is the archive commands flushes to Filecoin via, like I said, via a Node.js sidecar. And just to wrap up, I know this is a brief demo, but the actual documentation and a brief walkthrough on how to set up the project, the commands, and the technical documentation is available on the GitHub and will be provided. So thank you for your time.